And now this power comes to the MOSFETs. Obviously it's come to these two MOSFETs, upper MOSFETs, uh, and then we have uh, other two MOSFETs that's connected to the ground. I will not now detail whether it's the drain, source. Just now let's us assume that we deal with these transistors and MOSFETs as a normal switch. Of course there have to be the proper polarity be applied. Usually we have to drain. High voltages have to come to drains, not to sources. Sources usually are connected to ground. But let's now assume that these things are just a normal switches that you use in your everyday life, so that it's never be complicated sort of explanations. So this IC will turn two transistors from different sides at the same moment. Two different transistors from two different sides each moment. And for this I just draw this is as green and this as green to show that these two are turned on simultaneously, and these two are being turned on simultaneously. When these two are on, these two blue ones are off, and when these two blue ones are on, the green ones are off. Let's assume in the first case that these two green are turned on. For this, the voltage will be here as a high, and the voltage will here as a low, because we have a low resistance from ground to this outlet, and we have a high voltage from this bus and to this turned on MOSFET. So we have a positive here and negative here. At the second stage, there will happen something different. These two transistors are off, but these two are on, and this one will bring the positive now to the right side, and the negative, the left side will be this transistor blue one will be on, and will be there here will be a negative voltage. So the voltage in the perspective of these two, let's us see as your power socket or your outlet, will be just switching from positive to negative, and from negative to positive, and that's what AC basically is. It's true that AC is a sine wave, but yeah, I mean it's fluctuating between positive and negative. Each one outlet is not actually constant. And here we have an IC. Now I'm talking about this design, which I have seen hundreds of times in almost every single Chinese inverter. I have repaired thousands of them, and I have seen this design being repeated. And I would like to show you what's actually is going generally, so that it will enhance and improve your troubleshooting. At the heart of this inverter, there is an IC called LM324. It's basically a comparator, and this comparator have almost I think four. It's called the quad comparator. Maybe it has, as I remember, it has four different comparators. Each comparator has a tripping voltage, a voltage that if it reach, the comparator will produce a positive output. Let's make it simple as we can. Here we have OVP, which is a short of over voltage protection and over current protection and under voltage protection. When one, of course, there are four comparators. One that is observing this line, and once it's low, there will be a mechanism that I don't have to explain in details, but it's the work of a comparator. Comparator always has a reference, and if this reference violated in some way,